Question number 2. Okay, this is for 6 marks, so I have allotted 6 minutes to solve this. Let us see whether we will be able to solve it. Monochromatic light enters the ray base of a plastic beaker that contains water and an oil layer floating on it. Okay, you have a air, plastic, water, oil. Okay, there are 3 layers over here. Okay, the student draws a diagram showing directions of the light as it passes. Student diagram has one error at point A. At point A, he says there is an error. Okay, let us see. And one error at point B. Okay, one error at point B. Refractive index of materials are shown. Okay. Now, what is being asked? There are 2 errors here. We'll do one thing. We'll just make a note of this one here. One error here at point A and point B. There are 2 errors here. We need to identify that. That could be the angle. That could be one of the question. Definitely. Light is refracted at an angle of 32 degree. Okay. When it enters the plastic layer as shown. Okay, fine. Identify with the reason the error in the student's diagram for the light crossing the plastic water interface. Position A and position B. Okay, so as I told you, we need to identify which is that point. Okay, what is that error over here? Okay, now you see, let us first see any diagram. If this is the case, first write down which is a rarer, denser medium. Okay, see here, air refractive index is 1, so this should be rarer. 1.6. With respect to this is denser. Now here denser, this 1.33 is denser. Okay, so therefore 1.6. So this has a higher refractive index, lower refractive index. This should be rarer. Then 1.33, 1.47, rarer to denser it's going. Then denser to rarer it's going. Okay, we have written all these values. Next, what we should do? Now, when a ray goes from a rarer to a denser medium, it should bend away from the normal. This has been found. Now you look at this angle. So anyway, he is asking over here, this angle, some theta over here. Okay, so this definitely is bending towards the normal. So I don't think any issue is there. Okay, now let us look at this here. So it's going from denser to rarer. Okay, when I write, I'll write down denser to rarer bends away from the normal. Away from the normal. What do you mean by this? Which means that angle I should be less than R. Okay, see, so this is your angle I here. This is your angle R here. What's happening? The ulta is happening. Reverse is happening, right? Okay, so therefore, denser to rarer, it is bending towards the normal. So we have identified. Let us first see whether what is this point here. This point is your point A here, right? So what is the first question? Let us go step by step. Position A. Okay, so we'll write down. So from plastic to water, right? What is this interface? From plastic to water. We'll write down. So from plastic to water, refractive index is 1.60 to 1.33 or 1.32. What is given? It's 1.33. 1.33, which implies ray goes from denser to rarer. Therefore, bending should be away from the normal. Okay, so we have reason, we put the reason. Okay, and we have seen what is the mistake. We have identified the mistake and we have put the reason over here. Okay, since it is going from denser to rarer, we have mentioned this also. In other words, either you can put this reason or you can also put the reason as here I should be, it's going from denser to rarer, I should be less than R, but found, what did you found? I is greater than R. I is greater than R. Okay, so therefore this is one mistake. We have done this. Light of the water to oil interface. Now let us look at the second one. Water to oil interface, what happens? 1.33 to 1.47. So what's happening? This is from rarer to denser. Now what is shown? Reflection is shown, no refraction. Is this possible? Never possible, right? So you can't even argue saying it's total internal, because TIR will take place only when the ray of light goes from a denser to a rarer and not from a rarer to a denser. Okay, so therefore you can mention that water to oil interface is from water to oil interface is from, what is the refractive index? Refractive index is 1.33 to 1.47. Is from rarer to denser medium, since refractive indices are 1.33 to 1.47. Therefore, refraction is expected, but reflection is seen. You have to write the whole thing. Okay, only then you will get 2 marks. Therefore, B is incorrect. Okay. Now, second one also we are done. Then, calculate the angle of incidence in the air plastic interface. Air plastic interface. What is this? Where is air plastic interface? Here. Okay. Angle of incidence is asking. So what will I do? I will apply Snell's law here. So I will write 1 into sine theta is equal to refractive index of this medium, mu into, what is mu here? 1.6 into, what is this angle? Sine 32. Sine 32. So sine theta will be equal to 1.6 into sine 32. Now let us calculate what is this value. This value comes out to be sine 32 is what? I'll write 32 and then calculate the value of sine. I got this much. It's equal to so much. Multiply this by 1.6 and I get the answer as 0.847. 0.847. The value of theta would be arc sine inverse of 0.847, which would now be equal to, with the sine inverse, let me go here and click on second. Sine inverse of this value would be, I made a mistake again over here. Just a minute. 0.847, 0.847, and I will take sine inverse. It's 57.88 degrees. It's nearly 58 degrees only. This should be your answer. Let us see whether we have done all the three. 58 degrees only. Okay. Okay, so that's it. We have come to an end to this problem. Tomorrow we will see the next problem. Thank you. So do like, share and subscribe to my channel so that you will get more updates further to it, because the exams are nearing. I'll be putting more number of videos based on several topics. Thank you.